So here what I'm going to do is I'm going to take something that looks like this, let u equal the inside function so that I get f of u, and then the derivative, the g of x dx, will be what's here, and it gets replaced with a du. So let me show you what I mean. Always let u equal the inside function. So here it is. So if I do the derivative, du over dx, that gives me 8x. So the next step, I'm going to multiply by dx. Okay, so I'm going to take this and I'm going to suggest that you rewrite it. So 3 plus 4x squared, all to the fourth power, x dx. Okay, so I can take and put this in for this, right? The only thing I'm going to carry along is an integral sign. We're going to change it all from x's, all x's. And then here we're going to have an integral with all u's. So all that carries along is that integral sign. I see that this is u to the fourth power, right? I'll let u equal the inside, so I could have u to the fourth power. Now I need to work on getting this out. So I'm going to take out x dx, and I'm going to look at this line right here. Here is x dx. How about if I multiply both sides by 1/8? So 1/8 du is x dx. So if I take this out, I put in a 1/8 du. So I'm going to rewrite this. And then, oh, will you look at that? I've got the integral in u's, and I can take that integral. So I get u to the fifth over 5 plus c, so 1 over 40, and you have to put the x's back in at the end. And so then that's 3 plus 4x squared. So that's the answer. Okay, let me come and do the next one. So I've got this, again, never multiply these big powers out. So I'd say, okay, so this one here, I'd let u equal 3x plus 4. And then the du, and the du over dx, but I'm always going to multiply by the dx. So you could say 3 du over dx is 3, then du is 3 dx. Okay, again, all we carry along is the integral sign. So I'm going to take this and put the u in, so I have u to the fourth. Now I'm looking, I have a dx here that I want to replace with. Here's the dx. So if I multiply by 1/3, I get dx is equal to 1/3 du. And if I take the time to pull the 1/3 outside, I can clearly see this is an easy antiderivative. U to the fifth over 5 plus c. And then again, at the end, you have to plug the x's back in. So this would give me 1 over 15, 3x plus 4, all to the fifth power plus c. Okay. This one here, you could do a couple of different ways. I could do a u substitution, but I want you to always be looking out. So not every problem is going to be u substitution. Can you see that this does not have an exponent here, no power? Can I just multiply this out? I can. I get 64x plus 4x cubed. Well, I can take the antiderivative of that without a u substitution. I get 64x squared over 2 plus 4x to the fourth over 4 plus a c, right? So don't always go for the u because it's not necessary. And sometimes it won't work at all, and we'll talk about that. So that would be a fine answer. This one here, I do need a u substitution. You're always letting u equal the inside function. So I can see I'm going to let u equal x cubed plus 4. So x cubed plus 4. So again, you need to write it out. Maybe I want you to make sure you're writing the steps out neatly because this is just the beginning of integrals and they get hard. So du would be 3x squared dx. Again, I'm going to rewrite this guy. And I'm going to say this is like saying 1 over x cubed plus 4 to the fifth power times a 3x squared dx. Okay, so I see this is u, right? So integral 1 over u to the fifth. Now I'm looking at, I've got 3x squared dx. Well, you look at that. That's exactly what I have here. So that's du. So it's necessary to rewrite this as u to the negative 5. Now remember, integral increase, antiderivative increase the exponent. So I add 1 and put it over that same number. So negative 1/4. And then put the inside the u back in. Plus c.